Hi everyone, welcome back to our channel. Today we are going to solve this problem using voltage division rule, and the question asked is apply voltage division rule and find the voltage across 2.66 ohm resistor and voltage across 1.33 ohm resistor. So the method of solving this problem is it's very clear here. So we need to apply voltage division rule. Okay. So now the voltage across 2.66 ohms is equal to the formula is total source voltage. Okay. So total source voltage, I mean total voltage multiplied with, so the resistor where voltage is required. So this is the resistor where voltage is required is nothing but 2.66 is the resistor where voltage is required, divided by the sum of resistors which are connected in series. So these are the two resistors we can see here. These are the two resistors which are connected in series connection. Therefore we can write down the formula as sum of resistors connected in parallel. So this will very important. So now just apply the formula. So I want the voltage across 2.66 ohms. Total voltage is how much? 10 volts multiplied with, so resistor where voltage is required. I want the voltage across which resistor? 2.66. Multiply this with 2.66 divided by the sum of resistors which are connected in parallel. So this is nothing but 2.66 plus 1.33. So if you solve it using your calculator, you will be getting as 6.66 volts. Similarly, we need to find out the voltage across 1.33 ohm resistor. Okay, so the formula is total voltage. What is the total voltage given in the problem is 10 volts multiplied with, so resistor where voltage is required. Okay, resistor where voltage is required. Okay, so what is the resistor value where voltage we require is 1.33 divided by the sum of resistors which are connected in series. So you can see here the current 2.5 flows like this and it flows like this. I can say these two resistors are connected in series connection. So there's nothing but 2.66 plus 1.33. So therefore we can write it by using an calculator. You can solve it. You are going to get 3.33 volts. So now it's very clear how we obtain the values. So the resultant you are going to have, so this is nothing but a battery, and this is going to develop some drop. Okay, so this is going to create some, this is first resistor, this is second resistor. So what is the applied voltage is 10 volts. So whenever the current of 2.5 amperes flows, it enters as positive, it leaves as negative. It enters as positive, it leaves as negative. So what is the voltage we obtain here? So 6.66 volts. So what is the voltage obtained at this point? 3.33 volts. So you may get doubt whether we had done correct or not. So to cross check our answer, let us try to apply Kirchhoff's voltage law. Okay, so you can see here current is leaving. What is the leaving polarity of the voltage? Plus. This is plus 10 volts. Okay, so current is leaving. What is the leaving terminal of the voltage? Minus 6.66 volts. Current is leaving. What is the leaving terminal? Minus 3.33 volts. So now we can write down 10 volts is equal to, when you add also you will get 10 volts. Whenever source voltage is equal to load voltage, I can say that our KVL is verified. If the KVL is verified 100%, the answer is correct. That's how to verify KVL. So hope you're able to understand the problem. The voltage across 2.66, total voltage multiplied with the resistor where voltage is required. That's nothing but 2.66 divided by 2.66 plus 1.33. So this is into 1.33 divided by 2.66 into 1.33. So successfully we have been find the values of voltages at 6.66 at 2.66 ohm resistor and 1.33. So if you feel the content is useful to you, please like the video and share the content to your friends, those who are studying. And if you have any doubts, let me know in the comment section. I will answer your comments. So if you are watching the channel for the first time, subscribe to the channel with the name KV Tulasiram. This is a free channel for the development of students as well as for faculty. So thank you for watching. We'll meet in the next video. Yours obediently, Ram.